contains 4 white and 2 black balls. 4 white and 2 black balls. Another bag contains 3 balls, that is 3 balls each, that is 3 white and 3 black. Okay, bag 1 contains 4 white plus 2 black, and bag 2 contains 3 each, 3 white plus 3 black. A bag is selected at random and a ball is drawn. What is the probability that a white ball being drawn is? The probability of picking a white ball. How we can choose a white ball? We can choose bag 1 and then we can choose white ball, or we can choose bag 2 and we can choose from bag 2 we can choose white ball. What is the probability that bag 1 is chosen out of these two? There are only 2 bags. So probability of choosing bag 1 is 1 by 2. If you choose bag 1, what is the probability that white ball is chosen? 4 by 6. So 1 by 2 into 4 by 6 is the probability that white ball is being drawn from bag 1. Similarly, the probability that white ball is being drawn from bag 2 is probability of choosing bag 2, that is 1 by 2 into probability of taking white ball from bag 2, that is 3 by total balls are 6. 3 by 6. The total probability of choosing a white ball is choosing it from bag 1 plus choosing it from bag 2. That is 1 by 2 into 4 by 6 plus 1 by 2 into 3 by 6. 4 by 12 plus 3 by 12, that is 7 by 12. So the correct option is option D. Let's see the next question. X is a continuous random variable with probability density function given by f of x is equal to kx in the region 0 to 2, 2k in the region 2 to 4, minus kx plus 6k in the region 4 to 6. Now, what is the value of k? This is pretty simple. Any probability density function in the given range shall add up to, when you integrate it, it shall add up to 1. That means integral, the range given is 0 to 6. 0 to 6, f of x dx shall be equal to 1 for any probability density function of a continuous random variable. If it is discrete random variable, then it will be, instead of integration, it will be sigma. Now, integral 0 to 6, expand this function, this becomes integral 0 to 2 f of x. In 0 to 2, f of x definition is kx dx. In 2 to 4, f of x definition is 2k dx. In 4 to 6, f of x definition is minus kx plus 6k dx. That shall be equal to 1. Now, k into k is a constant. X dx integration is x square by 2 between limits 0 to 2 plus 2k into x between limits 2 to 4 plus minus kx. I will rather write it as minus k into x is x square by 2 between limits 4 to 6 plus 6k into x between limits 4 to 6, that shall be equal to 1. Now, x square by 2, when you substitute 2 and 0, it is 2 square by 2, that is 2. 0 will become 0 only, plus 2k into x between 4 to 2, that is 4 minus 2, minus k into x square by 2, that is 36 6 square, 36 by 2 minus 16 by 2. Plus 6k into 6 minus 4. I am just substituting the lower end and upper end. 2k plus 4 minus 2 is 2, that is 4k, plus 36 by 2 18, 16 by 2 8, 18 minus 8 is 10, minus 10k, plus 6k into 6 minus 4 is 2, plus 12k. This will be equal to, shall be equal to 1. 2k plus 4k, 6k minus 10k, minus 4k plus 12k, 8k. So 8k is equal to 1, implies k is equal to 1 by 8. So the option is B. Let's see the next question. The first moment about origin of binomial distribution is, this is a pretty much straight question. We know first moment about origin of any continuous distribution is its mean, and mean of binomial distribution is equal to NP. So the correct option is option A, where the second moment for binomial distribution is NPQ. Okay, let's go for the next question. Question number 30. For the regression equations, two regression equations were given to us. Y is equal to 0.516 x plus 33.73, x is equal to 0.512 y plus 32.52. The means of x and y are nearly. Four options were given. Okay, what we know to solve this equation is means of x and y would always satisfy or would always lie on the regression lines. Here the regression lines given are y is equal to so and so, x is equal to so and so. That means x bar and y bar are the means, would satisfy these two equations. Okay, this we know. So now rewriting this equation, substituting x bar and y bar, it becomes y bar is equal to 0.516 x bar plus 33.73 and x bar is equal to 0.512 y bar plus 32.52. So these two are the equations. Now you have to solve these two equations to find out what is x bar and what is y bar. If you try to solve it, because we have odd values here, it will take hell lot of a time. Okay, it will eat up your time. So what you can do is that you can apply a trick. If you see, the trick is just negate these two. Y bar minus x bar is equal to 0.516 minus x bar minus 0.512 y bar. Okay, plus 1 point, this is 33.73 minus 32.52 will be 321, 752, 321, so 1.21. Now this is approximately 0.516 of x bar minus 0.512 of y bar. If I bring this side, it becomes y bar plus 0.512 y bar, that is 1.512 y bar. Here it is minus x bar minus 0.516 x bar, that is minus 1.516 x bar, that will be equal to 1.21. Okay, approximately, say suppose approximately these two values are same, so I take out 1.512 as common, so this will be y bar minus x bar. This is approximately, I am writing it, is equal to 1.21. Okay, now y bar minus x bar will be equal to 1.21 by 1.512. Okay, this is not exactly, but this approximately is the same. That means this value would be somewhat less than 1. Correct, right? Around 15 nines or 15. This is 15 8 120, so approximately equal to 0.8. So you can find out two values in the given set where y bar and x bar are approximately 0.8 and y bar is greater. So if you see y bar, first thing is y bar and x bar are not equal, so B is not a correct option. And second thing is y bar is greater than x bar. Y bar is greater than x bar, so this can be one option. Y bar is greater than x bar, so this is not a correct option. Y bar is greater than x bar. Y bar is greater. In both of these cases, x is greater than y, so this is also not a correct option. So we have only left with option A. So what did I do here? 1.5, it is just approximation, because in one case he has given us equal values. If you just substitute x bar and y bar, if they are equal, x bar and y bar if they are equal, then this becomes, I mean, they will not satisfy. these two equations. So this right away we can throw it out. So by negating I have arrived at this. Approximately I am writing it as 1.512. Assume y bar minus x bar is equal to 1.21. So y bar minus x bar would be approximately equal to around 0.8, or approximately they will be separated by around close to 1 value. If you see all this, here y bar and x bar are separated by around 10. Here y bar and x bar are separated by around again 10. So these two cannot be the answers, and we know y bar and x bar are not same, so this also cannot be the answer, and the only option remaining is option A. So the correct option is option A. If you have to solve the given two equations, it would take, I mean, you have to have calculator to solve this equation. So here, how could I neglect this? I said I have neglected this. So how actually I could neglect this is because if you see, it is 1.512 y bar, this is 1.516 x bar. If say suppose I will rewrite it as 1.512 y bar minus, I will write this as 1.512 x bar minus 0.004 x bar. So these two together will give me 1.516 x bar, correct, right? So this will be equal to 1.21. Our x bar, if you see the options, our x bar and y bar are approximately of the order of 60 or 70. So what will be 0.004 into 60? It will be approximately equal to what value? 6 4s are 24. Okay. 0.04 into 6, that is approximately equal to some 0.2 or 0.02. Yeah, approximately equal to 0.2. So that point is actually very less number, so that we can actually neglect it. So we will be left with this. That's what I have done here. Okay, so these assumptions when we are doing, please check the options also, so that the assumptions that you are taking is valid or not.